Okay, what is a stack? Okay, stack is a data structure which supports last in first out property where you can only remove what is inserted last. You might have seen diagrams like this. You can only push from one side and you can only pop from one side. Well, okay, this is a stack. Okay, we all know the standard definition. We all know the standard applications. I don't want to do any plate analogy or some regular academic stuff. Okay, I just want to discuss how you would implement a stack in Java and how you would use it for a problem like main stack, I suppose. Now let's see here. Let's define our stack. What does it suppose? Okay. What does it support? Let's keep this generic for now. Now it can support pushing of the elements. Now now you can also say this. You can pop things out and you want to see which element is at the top of the stack and you want to see something like this, or you want to see if it is empty. Okay, now what we are going to do is we are going to implement a stack in Java. We can do in two different ways, using arrays, regular arrays, something like this, but it's size limited. You would have to know the size at first, or you would have to keep growing it. That would be amortized, and first you would something like a dynamic array you can implement it. Okay, mm, something like a linked list. You can have a linked list here. You can add from head, remove from head. This is a really easy way to implement stack actually. Okay, like let's see how we would implement this one. Yeah, let's make this separate. Okay, create go here. Stack this ought to be an interface. And we'll go copy it. We'll go here. I have to make this public. Okay. Let's implement a stack. Okay. Let's define our own array stack in Java, like how you would do with an array. Let's see it with array. Now let's again do it with a linked list. But in Java implementation itself, if you see the stack, okay, if you go here, not this one, come on, this one Java util stack. This is part of collections library. Java, you can have a stack here. So if you see how this is implemented, it extends vector. Vector is what? It's a dynamic array. You can see this is an array. Grow. You can see they are growing whenever they require. This is the growth function. How Java does it. Okay. You can explore this through IntelliJ. You can see the implementation in comments. I think this is supported by front load compiler. Okay. Now you can see it is just providing additional methods on top of the vector implementation. Okay, this is inheritance by the way, if you remember or not. Extends vector, you can do stuff like this, but for now we are just gonna implement a simple array stack so that you would understand how you can do it. Okay, now we're gonna remove this. Let's define our array stack. Array stack dot java. Okay, we have array stack. Okay, how do we want to do this? This is a generic stack, so we're gonna have to do generic stack as well. Okay, implements stack. Okay, we're gonna generate all the methods here. Implement methods. Okay, we need to satisfy these methods. Okay, since this is implement, I'm gonna remove it. It looks ugly. I'm gonna remove the annotation override. It looks ugly, four of them on consecutively. Let's see. Now since let's define our stack. Okay, this is of type T. Since we are using generics, so this would support any type of stack. Let's assume. Now what we're gonna do is we're gonna call this stack, and what we're gonna need is, let's say if you have array like this, 1 2 3, or okay, let me do this. Okay, you can have an array like this. Okay, you would insert element here, and you would insert element here. Okay, if you are popping, you can do this. Okay, so what we're gonna do is we can't put for example, we have to know, we have to track this, we have to track at which point we are currently in the stack. So what I'm gonna do is, so for example, you have to know the index at which you are on your stack. 1 2, now 3, and when I'm inserting, I can't traverse through the array and find the empty spot and then insert it, so it would be inefficient. So you're gonna have to keep an extra variable to track it, to track the index, which is top, let's say, and we're gonna need an empty stack as well, size. We're gonna track the size too. What we're going to do is ArrayStack. Here, let us define this array need to be initialized. If you know what I mean, this array needs to be initialized. Hmm. Okay, let's do two constructors here. One private static in final capacity. We'll do something like this. Whatever, like this. Here, I'm going to do an empty constructor. This is called overloading, by the way. Constructor overloading. Okay, let's see. Let's see. I will show I will show you an interesting bit with generics here, with Java generics. Okay, so let me show you. Okay, okay. If you go to this Java stack implementation, which uses vector, if you see here, vector has a type E element. This is the generic type you would pass. Okay, instead of using, I know if you see here, let's go through some additional implementation. Okay, wait. Last index. See, if you see element add function, it is returning the value of type E. Now, but if you see here, instead of, okay, this is read only file, instead of having E square brackets, something like this, T, something like this, they have object here. Why? That's what we will see. Because not the okay. Let me show you why. Now, when initializing uh, the array, see this dot stack is equal to. Let's not do this. Let's directly new of type T, and I'm gonna give default capacity. Okay. Now this is an error. Type you cannot initialize it directly because at this point of time Java doesn't know how to allocate memory for this type T because it can be anything during that. Or sorry, uh, this is a limitation of Java generics. So it's weird. I think Java should have been able to support this one, but uh, it doesn't. Cannot be instantiated directly. Type T because something to do with the compilation process where it doesn't know the type which type yet. So we're gonna have to do something like this. Something like this. Something like this. This will work. But ideally in a language where with better type system it will work. Maybe let's not just understand that you can't initialize the generic types directly. It's certainly a limitation of the language. We're not gonna go too deep into that right now, but let's keep that. Let's keep it object anyway, since the language itself does it. So now we have to know at which index our top is right now. Now we're gonna start at 0 because you see here. Now this is an empty stack we defined. We want to start here. Okay, and we're gonna go size is 0 now because there are 0 elements. Now capacity is different from size. Capacity is the size of the array, and this size variable is actual. Let's This size variable actually represents number of elements present in the stack. Now, did we initialize everything? Okay. Now I'm gonna go here. Capacity. Okay. Now I'm gonna do push. How okay. Mm, since push means we have to. So since this is an array based, array is fixed size. So we can't push any more than it can take. Otherwise, it would be index out of bounds exception. Okay, let's do it anyway for now. Okay, top is a variable where we are at. Okay, ideally, if you see here, if we start with the top here, so this would be empty. Okay, if you return pig on empty stack, it should return null. But there is nothing at the top of the stack because stack is empty. But if we want to be able to write peak like this. No, we want to be able to write peak function like this. So if we do this because of convenience anyway, right? Otherwise you're gonna have to check if top is at valid position or check if the stack is empty. So that's why I'm gonna put -1 here because we don't have anything yet in the stack. I'm gonna put -1, so top actually starts here. This is top. So if we have to insert an element where you can go like this here, if top is null, or better yet, we're gonna use this one. Okay, Okay, we're gonna use option. Okay, let's do fancy stuff. Let's do like this. Let's force our user to handle null pointers. Return the make p. Is that error here? Oh, sorry. Since we are implementing the interface here, this is why. Okay. Now we have a problem with this one. Okay. Let's be responsible about null pointer exceptions, which are $1 billion mistake in CS. That's fine. Okay, we're gonna do push here. So we would want to increment top. That means okay, top is tracking the current element. That means if you want to insert, you want to increment top, and then you should be able to insert. Let's do this. Okay, if top equal to throw new stack is already full. Now we're gonna have to handle this exception, but let's think about design later. Okay, actually, his runtime exception would be okay. Since you would be ideally when you write stack, you would use something like linked list. Okay, it's very rare that you would go out of memory error unless you are working with like really large data, and maybe in that case you wouldn't be using stack anyway. Since this is the limitation of using a static array to implement the stack, I'm gonna have to do this. Okay, let's not think too much here. Okay, this would do enough. Maybe maybe if you're not satisfied, you can do something nice. I don't know, define a custom exception, something like that. Maybe. Okay, for now. Okay, what we're gonna do is since top is equal to L, and we're gonna increase our size because we just implemented the stack. Okay. Okay, we're gonna do pop. Okay, first let's go and do empty is empty. Now is empty we can do size equal to 0 or top equal to -1. Okay, let's do this one because okay, we can do both are same only, there is no extra cost or next. Both are really simple. Okay, but you do have to increment the size when you are pushing, decrement the size when you are popping. That is mandatory, otherwise your is empty function would fail. Okay, that's really necessary. Okay, now let's do pop. Okay, let's say we want so if top is tracking current element, then store it, remove it, return the stored value, something like this. Okay, res is equal to stack dot. Okay, okay, yeah. Do you understand why I put this here? You can't pop from empty stack. Be mindful of it. Or do I really want to throw a runtime exception when you try to pop? Okay. Okay, this is the limitation of okay. Okay, now something like this. Your pop peak is also nice. This is the ArrayStack. Okay. Now let's see. Let's write some test for it. Let's test this one. Okay. Yeah, do I have JUnit here? Maybe. Ooh. Oh, JUnit bomb. Okay, JUnit is an Oracle maybe. That's later. We'll do it later. So, yeah. Okay, let's see. Let's. Uh-huh. So we'll give capacity 5. Okay. If you click here, it will go here. If you don't give capacity, it will go here. See, the capacity is not here. We'll use 256. We'll do with 5 enough for now. Okay. And for air, logitech, mx keys, meaning something like that. Something else to fail. Okay, if you do here, mm, okay, what I want to do. I do want to be able to print the stack though because we want to you wouldn't really need to be able to print the stack, but so okay, let's do it anyway because we want to see what we are doing to the stack. Okay. Dun, 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 dun. This would work. We should show this would fail. See, stack is already full. Stack is already full. This would fail. We would know that because we designed it, so it's working as expected. Now let's do op 6 times. Okay. Now on see. Now let's pop it 5 times. Okay, wait, why is it? Mm, okay, wait. What am I doing here? From stack. Why am I printing? Okay, this is a wait. You see, you do it properly. See, people, see, this is what you will do. Dumb mistake like me. Okay, we popped. Okay, we are gonna empty the value. You won't also need it, but since you are printing, it looks confused. I'm gonna do this. So, see, even if you are printing the stack potentialization, it looks like that only. See, both are same. Just initialize with. Why are we storing null though? Why do we need null? We don't need null actually, but okay. If you think about it, you don't have to put optional here. I decided to get fancy actually. Okay, this is a throwaway implementation. This is really stupid. Didn't really need optional since I'm already checking for bounds and throwing exception. This is an overkill to be honest. Okay, let's not do this. Don't do like me. Don't over engineer stuff. Now what we are gonna do is a linked stack. Okay, let's do a linked list anyway. Linked stack. Okay, so this is basically a linked list implementation. We're gonna do here same thing what we did before. Okay, you do like this actually instead of throwing exception. Yep, this will work. Yeah, yes. Here we're gonna define a node for our links node. We're gonna call it. Okay, our node is going to have a value and a pointer to the next link node. So something like this. Okay, I actually want to wrap this in an optional like this, but I don't know this thing. Okay, let's not get too complicated. Okay, so you don't really need optional here as well. Let's go ahead and okay, since we come to anyway, we'll do it. Okay, so let's do push. Let's define our values, mean values, not static anyway. We're gonna need a head. Peak is always going to be head. Is also is going to be head. We'll just gonna define size anyway. Since linked list is growable, unlike array, it is not restricted by a size. So we're not really having any capacity passed in here. So this is really easy. Push means we're just gonna create a new node. Okay, val here and new node becomes point the next pointer of new node to head and make new node the head. Okay, now what people get confused here with a linked stack explanation is, see, if you have something like this, okay, you have, okay, let's go here, let's do something val one. Okay, you would have something like this. Okay, and this points to this one. Okay, how it works in memory is, now this is a memory layout. Okay, and now this node, list node, let's call this node 1. Okay, let's call this node 2. So in memory, something, we have something like this, node 1 here, node 2 here. Okay, we can have 9872, something like this. Okay, this is the memory address of this node. This is the memory address of this node. Okay, I'm taking an example here, but so when you are doing head is equal to new node, you're not overwriting head. Let me show you how this works, by the way. Okay, let's go here. In your language, what you have to understand is uh, pointers. Pointers exist in Java also. You have to remember that. Okay, whenever you define an object and you store it in a variable, it is not literally storing the object in that variable. Rather, it is storing the address to that object. Okay, that is why concepts like shallow copy versus deep copy exist, because you are dealing with pointers. Okay, it makes it far easier to deal with pointers and memory with garbage collection and etc. But pointers still exist. Okay, when you're defining head here, which is of type list node, okay, it is a pointer. This is a pointer to the head, not actual node. Okay, that means head. Let's say first we have head here, node 1. Okay, that means this will have something like this. Okay, now let's do this. Let's delete this one. Okay, now okay, this is how it is. This is how it is defined. Okay, now here it is null or empty. Okay, when you main arrow mark here, this value contains the memory of this value, this node. This is where the write comes in. This one. Actually, do this here. Okay. Now let's see how inserting at the top works. This is a regular concept where when you're learning linked list for the first time, you tend to struggle. That's why I'm explaining. If you already know this, you can skip it. Okay. Initially, head is pointed to the node 1. Okay. Now when you are creating a new node, is something like this. Okay. Okay. As 3. Node 3. I'm gonna do node 3 and its address is 4567, something like this. Okay, what we are doing is node 3 should be inserted at the top. That means node 1, node 3, node 1, node 2. Okay, that means like this, something like this. Let's keep it here anyway. Okay, what is happening here? Now when you're defining new node, okay, let's say, okay, this node of val3. This means new node is storing address of node 3. Okay, this is creating the node list node object with val3 in the memory and returning the address of this value. So this means new node will contain. Okay, now let's see. Okay, now this is supposed to be inserted in front of this one. Okay, okay, this is supposed. Now this is how it's supposed to work. Okay, now what is happening here? Let's do now. Okay, let's write a simple linked list. Okay, now let's go deep into this stuff. I'm gonna do a list node of int. Now let's something like this. Now let's do push friend. Okay, something like this. Now we are here. We created a new node. Okay. Now let me do this. Okay. So there are two steps involved here. Okay. If you want to point this node to this, okay, you're gonna have to store address of this in here. Okay. So that means this will become here. Okay. Okay. All good. Now it is linked. Okay. Okay. Now now the trick. Okay. I have to copy this. Okay, this is wrong. Okay. I have to copy the address of this one and paste it here. Okay. Now we inserted node 3 at the top. Okay, now this is pointing to this one, now this is pointing to this one. Okay, that's all well and good. Now our head pointer is still at this one. It is pointing to 0x1234, which is node 1. And now if you are accessing the top element in the linked list, you use the pointer to the head. That means you still have access from here only. If you are not updating, where see right is equal to head. Okay, what is happening here? This is the right variable here, and you are storing the address of node 1 here. Okay, now if you still print stack, let's say, okay, okay, let's print stack. Okay, let's make this easy. Okay, and okay, let's we'll worry about this implementation later, but for now, okay, wait. Uh, let's do this. This is for testing purposes only. I will not write like running a list like this. I will not recommend writing a linked list like this, but it's okay. Now let's make this public for our manipulation purpose. Okay, int node. Sorry, this is an int node. Okay, node 1 is equal to new int node value 1 value 2. Okay, now let's put the head here. That means our head is storing the address of this one. Okay, node 1 is also address of the node 1 node actually. Okay, that is a memory address of the int node it is created, not the literal int node. Okay, now let's print this one. Okay, we forgot pointing here. That's why. Okay, our list is 1, 2. Okay, if we do this one like sll dot push front, now 3, new int node. Sorry, what am I doing? Okay, now your array is still printing from 1 to. Okay, that means this is really important. This is where you are tracking the head of your linked list. Okay, linked list is not a contiguous memory data structure where you can predict, you can directly access the value like 10th value, 11th value, or any value of that matter directly via variable you have. So if it is an array like this, something array of 5 means array is the starting point of that memory layout, and what compiler will do is it will give you the 4th block of that memory. Okay, this is how arrays work, and see, this is how arrays work. Since we are dealing with linked list, always keeping track of head pointer at the right place is important. Now if we did not update our head pointer with this node 3 address, we will lose this one. We don't have, we still linked this one to this node 3 to node 1, but have to keep track of we have to keep track of our head pointer. So that means we're gonna have to update like this. So okay, what is happening here? Then head pointer. Now we need head pointer to be stored with an address like this. Okay, since we already have the new node variable which is storing that, we can do like this. That's why it works. Now if you see 312 will print. Okay, this is how pushing works in linked list. Okay. Oh, okay. This is a tangent. Okay, popping. Popping works the same by the way. So you will store this value somewhere so that you can return it to the caller. Okay. You can store this node value. You can either return the node or the value present in the node. Okay, what we are gonna do is, okay, we're gonna call is empty first. If our head is null, we don't have any memory address, return true is empty. Okay, pop. Okay, why do we need? Okay, let's think about this. Okay, if is empty, we are not popping anything, so we are just gonna return empty. Okay, now we need this one head dot val. So we are storing this val3 because that's what the caller is expecting. Optional of t. Okay, t means this value val3, and now I'm now and now okay. Okay, now when we are removing from the top of the head, basically in the head pointer, instead of storing the node 3 value, you're gonna have to store the node 1 value, which is the memory address. Okay, if you see here, head is equal to new node means head is equal to 0x4567, which is what the current head or the first element of our linked list is storing. Now, what does head storing? Head dot write is currently pointed at 0x1234. That means the address of this one. Okay, removing this means we are going to simply point our head pointer to this node. Okay, and after you do that, when this when this memory address or when this object goes out of scope, garbage collection will take care of this and it will free the memory. If you are writing if you are writing stack in C or C++, you might have to do that on your own since we are working with the luxury of garbage collectors. So I don't think we need that right now. So what we are going to do is simply write like this: head is equal to head dot write. Okay, what will it do? It will just simply store the address of the next pointer in the head. Okay, how do we know the next pointer of the linked list of the head? Because it exists right here anyway. Okay, now return. Okay, this is how our pop works. Is empty. Okay, optional dot off. Okay, by this point of time I hope you understood this speak how everything works. Okay, we have to imagine how it is working in the memory. Okay, this is how a linked stack will work. Okay, same as this one, but let's remove this one anyway. Okay, I hope you understood what I wrote. Now this will work in a very similar fashion. Since there is no capacity, you can even write 10,000. You can push 10,000 values here. Okay. Okay, we can print something like this. Okay. Okay. Now to do. Okay, we are not conscious of our size right here. Okay. Have to forget. We are forgetting this one. Shh, shh. You see, this is how you would implement a linked stack. Okay, I think this video is already too long than I expected, but let's discuss main stack in the next another video. I will make the video.